Yeah, $500,000. So we're talking about like a $50 million kind of capability. Yes. Our planned gross margin for all the system is 50% or better. What we like is that when we got, we licensed interrogator technology. Interrogator technology is really the most costly part of the whole system. And we started looking at, okay, what will that cost? And we go through reviews and look at all the different options. And, of course, when we started, I had the team, I gave them a target. I said, the electronics has to cost X dollars per channel in order to meet our, profit. And the beauty of it is when they designed the system, and we had the review and they're going through all the cost roll-ups, they said, we're having a tough time, we're going to have to really figure out a way to make it cost more because, we're way below that cost target. I go like, wow, that is fantastic. So this interrogator is so important to us, and it's going to really help us make our margins. Yeah. Yeah, we're going to be an equipment provider, and if people want to do wireless, they could add that into our system, but we aren't planning on providing that. I mean, pretty much, we provide the data via fiber optic cable to, whatever their data receiving location, and we put it in the format. And then there's several formats, used in the industry. There, it's called SEG for Society of Explorational Geophysicists. There's like SEG-Y is a format, SEG-D, I think it's SEG-2 is a typical downhole one. We could adapt any of those formats such that the existing recording systems can record them. So it's kind of, the compatibility is easy, so it's seamless for them to switch from their existing technology to ours. Pardon me? Exactly, their system. I use an example. When I was at Lytton, and we were going to go put this system on a submarine, and at the time, the powerhouse in the defense industry was Lockheed Martin, and so we talked to the Navy, and the Navy says, "Oh, we want this," and then we go talk to Lockheed Martin, right? We say, "Okay, here we have this new fiber optic technology, and it's going to take the place of all these conventional sensors." And in discussions with them, they go, "You know what? If you could tie into our beamformer and just make the data such that it matches with our beamformer, that's what we would like. If you start trying to make your own beamformer, we're going to start thinking you're competing with us." So we go, "Okay, we'll give the data so it goes in your beamformer." And I'm finding the same thing in the oil industry. These people have these systems, and if we could tie into their existing stuff, they love it. If we're going to try to take over too much of their piece of the pie, they start kind of, stepping back a bit. So, it's sort of the same kind of thing. Yes, sir. Well, actually, you can, but actually a system. In other words, we don't sell just the interrogator. But yeah, you could call up an order system, and our delivery dates probably are a little out there because of our backlog, but yeah, and we could. So. No, I mean, we have systems, designs frozen, and we're making them and sending them out. If we have improvements, we say, okay, when should we kind of build this into the, the product? And we have typical, standard configuration management, so that we could track. Okay, this client had up to this level of, revision versus the next one. So if when we're dealing with them, we keep track of, say, if they want some spare part, we know which one to give them. But all these things we're setting up with our manufacturing capabilities. Yes. Well, we're sort of hoping it never really does, right? We always want them to be demanding, more than we can make, or at least as much as we can make. Wow, that's a tough question. We're trying to, meet it now real time, and we're having some struggles. In other words, some of our dates have moved a little bit to the left, but we're trying to fix to the point that when we give the client a delivery date, we're making it very realistic for him and us. So when we say we're going to get it to him, we get it to him, right? Because that's important in the oil and gas industry, because they need to do surveys, and if the equipment's not there when they're drilling, that's a big problem. So I don't know if that does that answer it, or?
Yeah, it's trying to get a sense of how much we get
Yes. Well, one of the things we're doing is that, we're stepping back a bit in that when we first went out there, we put together systems, and, people said, oh, you could do 200 degrees C, you could do 15,000 PSI, you could do all these things that are very, very exotic. And they wanted that, and they gave us orders for that. And we're making them. But we go, you know what? For microseismic, if you only need to go down 500 feet, you don't need high pressure, you don't need high temperature, you don't need a 25,000-pound brake strength cable, all these things are like. So we stepped back and said, you know what? We'll be making these things for the other guys, but in reality, we see our sweet spot as these microseismic systems that we're going to crank up by the thousands that are simple. So we stepped back and we're designing our own low-cost microseismic system that is simple to make, low temperature, low pressure, that we could crank out, easily and faster. And it could, and I'll give you one example. Okay, so let's say, cost-wise and time-wise, right? If you have a high-temperature system, you have a special coating on the fiber. That fiber costs, say X. If you have a low-temperature fiber, it costs like 0.04x. I mean, the cost of the fiber is, a couple percent compared to for low temperatures. For high temperature, the system cost goes down. The other part is it uses a standard coating on the fiber that can go up to on the order of about 150 degrees Fahrenheit. And for the shale stuff, that's all you need. If you want to strip a fiber that's for low temperature, you have a little stripping tool like you do with a wire. You clamp it, you pull it, and the coating comes off. You don't have to buy these $30,000 machines where you stick the thing in there and it grinds off the coating. I mean, there's just so much simpler to make, I should say. Oh, go ahead. Pardon me? Oh, no, typically, it's on the order, and ask our sales guy. I mean, what are we, about 90 days to? Yeah. Right now, yes. One system, yes. Well, there's a couple, and we're working that. In other words, there's some long leads on certain items, so we're trying to figure out, okay, if we standardize on say a lead cable, which is the cable that goes from the sensor, the topmost sensor in the well, to the electronics. If we could standardize on that, we could just buy it, because typically it takes 8 to 10 weeks to get the cable. So since if we don't have something standard, we can't stock it. You see what I'm saying? So we could envision that once we standardize, on certain products, we could have a lot of cable sitting there, and the biggest lead time item, which is the cable, goes away. So, that also, helps a lot. But You know, those are the kind of things we're looking at. But it requires a standardized system. Oh, yes? Oh. No, we do have patents on the sensor too, but the sensor, cost-wise, you know, is relatively simple, and you know we can automate it and we make it. Right now, our electronics is not at that point. With this new PC-based, we'll be there.
So your intent is to become de facto, standard United States for sensors.
Absolutely,
So,
yes.
so it seems like either preference, so that either you can license your technology for manufacturing, or other people to sell, the interrogator, which might be more difficult. It seems to make more sense to probably partner with a company like Corning, that has more technology, probably better manufacturing expertise than you do with manufacturing.
Oh, we don't manufacture the fiber optic cable. Like, for example, we just buy it. We specify it, and we get big cable. You'll see all these big spools of cable. So we specify what we want, and then these cable companies make it for us. So, you know, we specify which fiber to put in it, you know, what coating, what the different, you know, features we want in the fiber, like what kind of loss and these kind of things.
It seems like to have that capacity to become you probably have to license the manufacturing technology. When you do that, you partner with somebody else that's more expert in
Well, possibly. Let me take. Could I go somewhere within? It's like, for example, you look at really the only thing right now that we have to really make in house is the sensor, because there's not a lot of people that do it. So we make these automated winders and stuff to do that. But the cables we get made, the electronics we get made, and the beauty of the new PC-based thing is we're moving away from what is called a hardware-based solution to a software-based solution. In other words, so we have an interrogator and we buy certain things almost off the shelf, we load in our software and it's done. I mean, I'm simplifying it, but we don't have to build a bunch of circuit boards, integrate them all together, put them into a box, and you know what I mean? It's just a better way of doing things based on, you know, with the software-based system. So that really gives us a big advantage. So, you know, I guess to answer your question is, if we have to end up making millions of course we'll have to do that, and we will. But, you know, for the near term, where we're in thousands and tens of thousands, you know, we could see with a couple automated winding stations that could put out, you know, on the order of, you know, 1,000 a day, you know, we can keep up with that, you know, for the geophones, we can keep up with that. And the electronics and things like that, if we need to, we can outsource them, because we don't have to make those in-house. Cables we already outsource. So we do like